So this is our last section in the transformations unit, and we're dealing with dilations. So dilations deal with changing the size of an object. So our definition is that a dilation with a center at point C, so we have a center of our dilation, and we have a scale factor. Keep in mind that the word factor is referring to a multiplication. So we have a scale factor, which we use the letter K, is the transformation that maps every point P in a plane to the point P prime so that the following properties are true. So we have one property if P is not the center, and we have another property if P is at the center. So if P is not at the center, so we have our center and our point P, and the image P prime lies on the ray that goes from our center to our point. So it can either lie between the center and the pre-image, or it can lie after the pre-image. Our scale factor is a positive number such that K is our comparison of the image measurement to the pre-image measurement. So we're going to get our scale factor by comparing the distance from our image to the distance from our pre-image. And whenever you're doing a scale factor, you always want to simplify that fraction. If our point P is actually the center point, then our P prime is going to be at the same location, kind of like when our point was on the line of reflection or at the center of our rotation, it didn't go anywhere. Excuse me. So we have two types of dilations. So we have a reduction. This is where our image is closer to the center than the original object. When we have a reduction, we're making our object smaller, and our scale factor is between 0 and 1. And then if our image is farther away from the center, we're making the object larger, so we have an enlargement. And when this happens, our scale factor is greater than 1. If I give you the coordinates of a pre-image and ask you for the coordinates of the image, we simply multiply everything by the scale factor. So we multiply each coordinate by the scale factor. So we're going to look at these problems and we're going to identify whether we have a reduction, which is when our new shape is smaller, or an enlargement, that's when the new shape is larger. And then we're going to find the scale factor by setting up a ratio that compares our new measurement to the original. And keep in mind that when we're doing the scale factor, we always want to reduce the fractions. You always want to simplify. So our first task here is to actually go through the diagrams and identify the original shape. So our original shape is going to be identified with the point P. So if we go through and we find the shape that has the point P beside it, those are the original objects in our dilation. And then we need to go and find our image. So those are the ones with the P prime. So when you find the P prime, that's our image. So the P prime is the image. Now, the other lines that are drawn within the object are the rays that go from our center to the vertices of each shape. So these are triangles, so you see three kind of starburst shapes there. So those are the rays going from our center to the vertices of our objects. So when we're looking at making the decision between a reduction or an enlargement, we compare our new shape size to the original. So in problem 1, the newer shape is smaller, so this is a reduction. In problem 2, the new shape is larger, so it is an enlargement. And in problem 3, the new shape is larger, so it is an enlargement. For the scale factor, we're going to set up a fraction where we compare a set of corresponding measurements. So if we look, we have a measurement on the left side of problem 1. We're going to use those numbers. It's just a matter of making sure we put them in the correct order within the scale factor. So we always go from the center to our image for the first number, and then we go from our center to our pre-image for the bottom number, and then you always need to remember to reduce the fraction. So this particular reduction is reducing the shape by a half. So our scale factor is the comparison of our corresponding measurements. So in this one, we have measurements on the right side. We always go from the center to our image for the top of the scale factor, and then from our center to our pre-image for the bottom of the scale factor. You can leave this one as 15/7, or if you like to do mixed numbers, you can do 2 1/7. So our enlargement, so our new shape is 2 1/7 times larger than the original. Our scale factor of the last one, we have measurements on the right side. So these are our corresponding measurements. We always go from the center to our image for the top part of our scale factor, and then from our center to our pre-image for the denominator. So when you simplify this, it is 5/2, or if you like mixed numbers, it is 2 1/2. So this is an enlargement where our new shape is 2 1/2 times the size of the original. If we're using the origin as our center of dilation and you are given a scale factor, and we're going to find the coordinates of the vertices of the image, we simply multiply by the scale factor. So we are going to multiply by the scale factor. So for each ordered pair, every coordinate is simply multiplied by the scale factor. So for L prime, we're going to do 2 times 3 and 2 times 0. For M prime, we're going to do 2 times 0 and 2 times 4. And for N prime, we're going to do 2 times 3 and 2 times 4. Always be careful if you are getting the coordinates on your own, because not every graph is numbered by ones. So be careful if you're numbered by something other than ones when you're identifying your coordinates of G, H, and I, that you're counting by twos. And now we're just going to take each of those values and we're going to multiply them by half. So for G prime, we take half of 2 and half of 8. For H prime, we take half of 6. And for I prime, we take half of 4 and half of 2. So you simply multiply every coordinate by the scale factor. So every number gets multiplied by the scale factor. We can also use the scale factor to find missing measurements within an object. So you are making hand shadows on a wall using a flashlight. You hold your hand 1 foot from the flashlight and 5 feet from the wall. So your hand is 1 foot from the flashlight and your hand is 5 feet from the wall. So this means that our flashlight is 6 feet from the wall. Our hand is parallel to the wall. And we have a measurement from the thumb to the ring finger is 6 inches. And we want to know what that measurement is for the shadow. So we're looking for finding a measurement on the shadow. Our first step of the process is to find the scale factor. So our first step is to find the scale factor. So when we look at our object, I have a measurement that goes from this flashlight, which is my center, to the hand, and then from my flashlight to the shadow. So this is my corresponding measurement. So that 5-foot measurement isn't part of my scale factor. I have to go from the center to the hand and then from the center to the shadow. So when I fill in my scale factor, from the center to the hand is 1 foot, from the center to the shadow is 6 feet, because we always go to the new shape first. So from the center to the shadow is 6 feet. From the center to the hand is 1. So this is a scale factor of 6 to 1. So next we're going to find the missing measure. And our scale factor is a multiplier. So if we take the scale factor and multiply it by the pre-image, which in this case is our hand measurement, then it should give us our image value, which in this case is the shadow. So for our problem, our scale factor is 6 to 1. We're going to multiply this by the measurement in the hand. So for the hand, this is a 6-inch measurement. And when we multiply 6 over 1 times 6, we get 36. And keep in mind, we have to use the same units. So from the finger to the thumb is in inches. So we have a 36 inches in our diagram. So from the ring finger to the thumb is going to end up being 36 inches in the shadow. So if it's 6 inches on the hand, it's going to be 36 inches on the shadow.